If we take a look at the spreadsheet, looking at column A, we can see evaporation figures taken from a Class A pan. To keep the spreadsheet simple, we've used Class A pan because the Class A pan is more readily available. But this figure is corrected by multiplying the Class A pan by 0.8. This is simply because the Class A pan tends to read a little higher than ETO, the evapotranspiration figure that's calculated at a weather station. So column A on this screen shows the accumulated evaporation for each month from September to May. And you'll see that the evapotranspiration or evaporation increases in spring through to summer where it peaks, and then decreases as we move into autumn. In column C, we have the effective area of shade I've described. And here we see that in spring, the canopy, an orchard canopy, tends to be smaller. So we've used a figure of 10% canopy cover or area of shade, and it increases to a peak in midsummer where it reaches a figure of 50% and then gradually decreases as we move into autumn. The crop coefficient is automatically calculated if we nominate the crop that we're using. In this case, we've nominated a crop coefficient of 1.1, which is often used in peaches and berries. The stress coefficient in column E is where we can, on purpose, introduce a stress on the plant in a technique called regulated deficit irrigation. In many cases, we won't need to change that figure, but if we wish to save water at strategic times, we can increase that figure and reduce the amount of water used. Then we find that if these figures are entered for each month, we have a crop water use shown in column F, which is the calculated amount of water the tree needs. But of course, if we do get rainfall, which is recorded in column G, that is subtracted from the estimated crop water use, and we get a figure in column H where we have the actual irrigation requirement for each month. So the irrigation requirement tells us how much water we'll need each month, planning ahead. So this sheet is useful for planning operations on the farm, so we know how much water we'll need for the coming months. If we total these figures, we get a total figure in millimetres, and if we divide that total by 100, we get the estimated irrigation water required for the crop in megalitres. Now, if we change the evaporation figures in column A, you'll see that the graph shown below will also change the amount of water required on the farm. And the same applies to rainfall, that if the rainfall increases or we don't get rain, it will also be shown on the graph. The graph is interactive, so as soon as we make changes, it's reflected in the curve shown on the graph. Again on the graph, the blue line represents the evaporation figures, the black line represents rainfall, the green line represents the calculated water use through the water budget model, and the red line reflects the actual amount of water applied to the crop. And you'll see that where the rainfall is high, less water is needed on farm, and when there is no rain, that in fact the amount of water applied to the crop is the same as the predicted amount of water needed. In the water budget sheet, sheet number 1, we see a figure for irrigation application efficiency expressed as a percentage. Now, this is to describe the type of irrigation used on the property, and the figure can be changed. For example, if we're using flood irrigation, the figure would tend to be lower, so a lower estimate is used. If we're using drip irrigation or micro irrigation, the figure is higher. In this example, we have drip irrigation, so the figure is set at 90%.